Thank you very much. Thank you for the introduction, Rodriguez, and thanks for inviting me here. I'm a big fan of Norrköping, by the way, partly because we have a summer house outside Norrköping. Wow. This is a little bit like coming home. Even though we usually go here in summertime. Okay, so I should share my screen as you. Great. This one. Now I think it works. Okay, good. So the idea is to talk about human nature interaction using a network perspective. So I'm going to talk about social-ecological networks and how we have been using them in different cases and contexts and so on. But I would actually start with more social networks, first part, and then I will move into social-ecological. That's the idea. Let's see. And I thought, like, give a little bit of context. So what we are focusing on quite much at the Stockholm Resilience Center, where I'm from, sustainability science or sustainability challenges, and there are of course many of them. Here we have a couple of them: climate change, decreased biodiversity, social-economic issues, and so on. But I think a common denominator of many of these challenges is that it's really hard for a single actor, organization, country, or something to deal with those challenges by themselves. So some kind of collaboration is typically needed to address these problems. And you hear that quite often, that we have this issue, we have this problem, we need to collaborate and so on, and I entirely agree with that. But I think the question is a little bit more complicated than we just collaborate and then it's just going to work. We have to analyze and think about and discuss and actually question collaboration, I think, to a greater extent that we maybe are doing today, at least in some disciplines. Let's see here. So, the screen's kind of messed up a little bit with the Zoom stuff, but I hope you can read it. So that's why I'm using a network perspective, a social network perspective, to investigate and think about collaboration. Of course, you can think about collaborations in many, many different ways. You don't have to apply a network perspective or network approach, but I like it because I see like two major things with this network perspective. It gives you a vehicle, as I sometimes call it, to focus on the actors and their relationships clearly, which means that you have a focus on the actor, but you put the actor in context in terms of who else or is that actor connected to. A little bit like the social and ecological neighborhood of those actors. But of course, it can also be used to study the group as an entity by itself. And in that case, you might say that the research object is the network, the entire set of actors and how they connect to each other and how they do not connect to each other and what kind of links or relationship and ties they have and so on. So then it kind of moves up on the group level, but you're still using the same perspective. And quite often you can move in between. So some of the studies are actually using the same data. The focus could be on the individual. Why would an individual choose to do this and that and so on? And why would an individual connect with this other person or not? You can also look at the same data and think about the group. Why is this group behaving in certain ways? Can give you some clues. Of course, when you apply this in the group level, it's more data intensive, since in a way, a group is just one data point, and then you typically need to have more networks. Getting network data is typically quite a laborsome thing to do. But the point is, like, you can use this network perspective in many, I would say, very different ways. English. Some examples of networks. So here are three examples. I'm pretty sure that you are pretty network aware here, so I shouldn't spend too much time on this, but just three examples of networks that are somehow related to environmental problems or environmental governance issues. So we have two man and biosphere reserves here, and we have one network of small-scale fisheries in Kenya, and the different colors in that case represent different fishing gears. Just an illustration. The network can illustrate the actors, the nodes, how they relate to each other, but also certain attributes of importance, or maybe not importance, in terms of who the actors are, now being represented by different colors in this figure. Okay, but I want to focus quite much on my presentation here about what is the network? Is it the outcome, or is it like the dependent or the independent variable? And I would say it can be both. Depends on what kind of perspective you apply and how you think about what you try to explain. What is the phenomenon of interest here? And I actually took this slide from Steve Alexander to say that. So you can think about the network being the independent variable, the explanatory variable that maybe could say something about outcome, which could be on the individual level or the group level. But you have a network, and in a way you consider the network as being given, it's fixed. And with this specific network, what kind of outcome would you expect, given the structure and composition of the network? You can also think about the network as a dependent. You have an observation of the network, a social network, a social-ecological network, and then maybe the focus of attention is rather, why do we have this network? Why are actors forming ties in the way that we have now observed? What kind of processes are behind those choices? Can we essentially get into the heads of the individuals by investigating their choices of collaborating partners, for example, or with the ones that they choose to have in conflict? So it's in a way, one can think about the network as the fingerprint of the different various social processes, that at least some of them manifest themselves in choices of others to engage with, given consideration of different type of ties, of course. So it could be both the dependent and independent variable. And since I'm here, and I'm pretty sure that you are very familiar with Coleman's boat or bathtub. I'm not so familiar with it, I have to admit, but I thought this is a good opportunity to dig a little bit into that framework of thinking. And I am relying here on a paper, it's partly a paper that came out last year by Siciliana et al. In Cambridge University Press. It's a kind of book thing, I think. It's called Elementary. It's a short book. And they present a framework here. And I like it because it explicates many of these causal assumptions that I think many of the network scholars have, but they haven't not necessarily explicated them that much. So I think it's quite good, helping us to think about network as a dependent or independent variable, and also thinking about macro level effects versus micro level effects and how they cannot come together. So you're familiar with this one. So I think I will mostly say something about how it could be related to a network thinking. And this first part here, the network formation, would be like in this case, the network is the dependent variable, the thing to explain. The outcome here is actually the network, shape of the network and the composition of the network. And the starting point here would be like the environment, the context. The context itself can more or less directly also influence how the network would look like in the end. So there's this macro to macro link, but also the context influence individuals. And part of that influences how individuals make choices in terms of who else they should connect with or not connect with, and so on. So then you get into the dyad level, where you focus on the actors and their relationships. And of course, if many actors make these choices, it builds up to something up here. So it builds up to the network. So these different steps illustrate, I would say, how you can reason around the network as a dependent variable, as the outcome, the collective result of all these various choices that people make on various levels. So that, and then, of course, specifically from a sustainability challenge point of view, at least partly, the objective is to think about how can we, for example, how can we manage the nature in a more sustainable way? And then the interest is, okay, we have a network, or the network was created by some certain process and so on, but is that network or group of actors, are they well suited to deal with the environmental problems. And then the focus would be here on the outcome, the network effects. This network actually good or bad for this desired or not so desired outcome. And the same kind of reason, you have some kind of macro effect directly from the composition of the network to the system level outcome, which could, for example, be their ability to manage a resource. But also like the network in itself provides context for an individual. And depending on where you are in that network, your situation will be quite different. And that would also here influence how you act. You know, this is not the choices in terms of who else you should connect with. Actually, you have the feedback effect there as well. This is more in terms like if you're a farmer, you want to invest in more sustainable agricultural practices or not. And part of that could be derived from where you are in the network and who are your friends. You can think about social influence there, for example. And then, of course, what all the individuals are doing builds up to something that could essentially be seen as an aggregate effect on the macro level. So I think this is quite useful in terms of thinking about how to think about networks, social and social-ecological. I just want to say that we had a paper that came out. We kind of moved into this reasoning as well, but I think the Coleman vote is nicer instead of having a big table with a lot of text that people don't have the energy to read anyways. So the Coleman vote is pretty good. So what I want to do here, I'm going to try to use the Coleman vote with this multi-level network framework by Siciano and evaluate my previous studies. And I haven't thought through this that much. So any feedback is very welcome. So this is a little bit like an experiment from my side. But I thought this is a good venue for doing some of these experimentations, since you know the Coleman votes. So it's more. So, oh, I lost something. Did I move? I moved. Good move. They can still see me online.
On Zoom is fine.
Yeah.
The local
projector. Technology. This is a good time for me to have a sip of my coffee. Should I just continue? You could.
Jag har inte så apart from picking it off.
If you take another computer and connect to it, connect to Zoom, you can share the screen. Yeah. Okay, so as I said, this is going to be, the first part is going to be on a social network. This is based on a study that we did some time ago. I just want to continue now, even though you're at the room, you can't see the screen. So this is a study that we did many years ago, so several years ago, focused on ecosystem-based. So what is ecosystem-based management? It's a term that is used, I would say, in different ways. But I would say if you look for some common denominator, what is ecosystem-based management? It places an ecosystem perspective, which means that, for example, like nature should be seen as a composition of different entities, like a system instead of individual species or individual habitat patterns and so on. Kind of embraces the perspective that nature is a system, as are societies. Adaptive management is an important component here, meaning that we should adjust our management practices as we learn. As we get feedback from nature, we should adjust, which means that learning and collaboration are very important ingredients, I would say, in ecosystem-based management. You need to learn. And again, since no one is typically able to manage the system by him or herself, you need to collaborate. It's a nice idea. But still, I would say it's a question like how to accomplish ecosystem-based management, because it's super difficult. If you really follow the book, all these guidelines on ecosystem-based management, it means that you have to take everything into consideration, all aspects of the ecosystem and all aspects of society, and of course that's hard. So it's hard to say if you have really accomplished ecosystem-based management or not, to what extent, and so on. So in this study, we tried to disentangle that a little bit and we thought about three key dimensions of ecosystem-based management. And in terms of abilities of the ones trying to do this. So the first one here is the system thinking integration across ecological aspects and management policy phases. That means the ability to think in terms of systems. And systems should not only be about nature and ecosystem, but also like how people and stakeholders and so on, how they perceive and act and rely upon nature in various ways. That's one aspect. The other aspect, conflict resolution. Since we talk about conflict resource management, in many cases, open access resource management, it means that you have more or less an inbuilt conflict. People have different interests in how to use the environment, which means that if you want to accomplish ecosystem-based management, these conflicts need to be managed in some way. Not necessarily try to rub them out, but try to manage them. Don't pretend they are not there, but try to do something, compromises, negotiation, give and take, and so on. And then the third one here is, I call it just details. I mean, the reason I put it in here is that it's not totally uncommon. I would actually say it's fairly common that if you look at different initiatives that have tried to accomplish ecosystem-based management, we haven't really gone into the details how to do it, because it's a very challenging thing to do. And I would say it's not enough to say we are planning to do this, or we are following this ecosystem-based management approach. Like, ideally, you want to see more details around that. How is that going to happen? So I think we call it specificity here, and if the actors doing ecosystem-based management don't get into details, at least I would question that they actually are able to do much beyond talking. So three different key dimensions to succeed with ecosystem-based management. Again, like we focus on collaboration here, and then we think about what kind of abilities are needed to do so. What kind of networks possesses those abilities, the three different dimensions of ecosystem-based management? Do we have any clues about that? And can we even test some clues empirically? That was the objective for this study. The case we have that we were applying this thinking on was an initiative that more than 10 years ago now, but that was initiated by the Swedish Environmental Protection Agency and had 5 pilot areas. And those areas, they were charged with the objective to come up with the integrated management plan in the coastal area. So they got some support for that, some funding, but the objective was to bring together a diverse set of stakeholders and agree on a plan that should ideally then be used by, for example, municipalities and others to implement those ideas into something more actionable. So that there was an expectation for some very concrete outcome in terms of plans, comprehensive plans. And what we did here, we did a network analysis or gather network data from these 5 cases. And we also tried to assess to what extent their management plans or these plans for ecosystem-based management actually fulfilled these 3 different dimensions. So we came up with constructed a device to evaluate how much of systems thinking they actually had in their plan, how much of specificity and how much of conflict resolution. So we can actually score that in some way there. But before getting into that, so we have these 3 different capacities in terms of accomplishing ecosystem-based management. And then this is kind of our hypothesis building phase here. So we talked about specificity here. And the collaborative ability here is called collective action, meaning that if you want to move just beyond this kind of shallow statements, you actually have to engage in something collectively. That's an ability. It's pretty unspecified, but still specificity itself is not specified. So we felt like there's a kind of a match here. And then the other dimension, systems thinking and integration, that is quite much about solving compounded problem, complicated problem, cross-disciplinary problem, where you need to combine different knowledges and expertise. That's a specific ability. And then the final one, the conflict resolution, and that would be solving contested problem. don't shy away from conflicts, address conflicts, try to mitigate them, manage them, maybe find some common ground. So 3 different abilities relating to 3 different dimensions of management. And then, of course, we want to bring the network perspective in here. And here comes my Coleman-Bode experiment. So the first one, collective action. How would the network look if you want to enable collective action? This is the most basic hypothesis here, like essentially saying that if you have a network with many links, many relationships among the actors, they would be more able to do something together. And of course, it makes sense. If you have 0 links in the network, it's going to be hard for those actors to communicate. But of course, you can question like the more links you have, the better it would be. I'm actually quite skeptical about that, but you need to have some links. But this idea, this hypothesis would be like many links, better ability to accomplish collective action, and then you would expect to see more specificity in the plan. And in the Coleman-Bode thing, which you can see a little bit here, so what we are looking at here is a net. First of all, like we focus on the outcome, their ability to come up with these plans with these different qualities. So it's a network level thing in terms of do you have many links or few links in this network, but it's also a dyad thing, building on the assumption that if 2 actors do have a social tie, their ability to collaborate is higher than if they don't have it. I'm not entirely sure this is a correct use of Coleman-Bode, but that's part of the experiment. So you have the network level thing, like density of ties, and you also have the inbuilt assumption that individual actors will be more able to do something together if they have ties with others, and the more the merrier. Then we have this compounded problem. The compounded problem, ability to accomplish system thinking. And what we started from here was this pretty, I would say, accepted proposition that if you have diversity, you have different backgrounds and different experiences in the group, in theory, the ability to solve the compounded problem should be higher, instead of everyone being, thinking exactly the same way. So diversity would be good in that sense. And this first thing would be like, it's a network level thing, I would say, like, because this would be like a composition of the network in terms of different backgrounds and experiences and education level and so on. So the more diversity, the better you would be to come up with this solution to difficult problems, essentially. But this is a network without links. So if we take this a little bit further, you can question, like, of course, if you have this room full of diverse people, but they don't communicate, I really don't see the point with diversity. So you need to have links there. Otherwise, that diversity is not being utilized. And then you can say, like, the more links you have between actors with different, I call them types here, the higher ability there would be for them to come up with more integrated solutions. And in Coleman-Bode perspective, that means, again, this is a network level effect. You have ties. Now you have ties between actors with different backgrounds and different knowledges. But there's also a dyad effect here. It's like, so if 2 actors with different backgrounds communicate, work together, they can do something which is more than they could do together. So 2 + 2 = 5 or something like that. So in the Coleman-Bode perspective, I see these 2 kind of drivers on that specific ability. You can also think about, there's another way to utilize that diversity, and that is, instead of having all of these people connected to each other, you can have a facilitator. You can have someone being in the middle and taking care of gathering all that diverse knowledge and coming up with something good. A facilitator. This is sometimes called like a network administrative organization or a hub or an entrepreneur or something like that. But it's typically based on the assumption that you have some actor or actors in the middle that can help to bring these different knowledges together. It's same diversity of the group, but the network looks very different. In this case, it's a highly centralized network. Coleman-Bode thing would be still as a network level effect. You have a dyad thing here, but I also added this node level effect because here you have a specific position of an individual in the network could influence that individual's ability to do something. And in that case, you can think about the central actor being the person then, or the actor being able to utilize that structural position in combining these different knowledges. I essentially covered everything in the Coleman book with this assumption. Okay, and then finally, conflict resolution, deal with contested problems. And here we relied on what has been named the risk hypothesis. It was developed by Schultz and Berardo, I think, 10 years ago. And it's more than just the triangles here, but part of that hypothesis is that if you are forming a closed triangle versus an open triangle, the ability for those actors to deal with problems that involves risks. And if you try to deal with a conflict, that's a risky thing, because the risk you take when you try to address a conflict is you might lose out, you might be the loser, the sucker in the game. So it's a high risk collaborative problem versus something which is not conflict driven. And based on that hypothesis, you could say that if you have a closed triangle, the ability for the actors to address conflicting issues would be higher than if they don't have a closed triangle. This is partly derived from social pressure, for example. So if these actors agree on something and you have ties between all actors, it's easier for them to exert pressure on in this case, all the three actors to actually comply to that agreement. That's one of the mechanisms here. And if you think about this in a Coleman-Bolt perspective, it's a network level effect, but that will be more in terms of how many triangles you find in networks. I think this effect is more on the micro level. So it's a node level and a diode level thing here, because this little substructure creates a social content, like a local social content for actors that could help them or prevent them from behaving in certain ways. Okay, so if we bring all this together, we have a couple of hypotheses in terms of the network characteristics and those abilities that would ideally then lead to different outcomes in terms of their ability to accomplish ecosystem-based management. That's what this figure here. And quickly, we had this outcome on the EBM based on the management plan. We have some variability among the cases, 5 cases here. The networks. We did some exponential random graph modeling. I'm going to talk a little bit more about that later, so I'm just going to skip it right. And what we essentially did here in the end, we tested those hypotheses, and I had this thing on test because like we have 5 cases. It's not much from a statistical point of view, and at least one of the cases I consider being a little bit of an outlier. That's the red one up here, Norra Bohuslän. It's an outlier because this was not like they were not started from scratch when they had the initiative. They were just building on some previous initiatives. They had a very significant head start at the initiative, which we think could explain that they were a little bit different from the others. But still, it was a qualitative test of these hypotheses. Yes?
Can I ask a question?
Sure.
I just want to ask about the data. So what you did was you went through the plans, and wherever it said municipalities should do this with these, you just checked municipality as an actor. So you kind of like went through the plan and coded it.
No slides. We had a separate survey for the social relationship.
Okay.
So we asked each and everyone being part of those 5 different initiatives to nominate the collaborators and to what extent the collaborators and so on. So that was one set of data. And then we had a look at the management plan, and then we evaluate them based on the tool that was developed. We kind of graded them in terms of specificity, and if they try to address the conflicts instead of just trying to avoid them. And then the part of the system thinking, so we had some criteria like what would be the signs of system thinking?
Okay, so the networks came from the survey.
Yes, so there, I think that's a good question, because it's otherwise it would be kind of circular.
Yeah, that's okay.
So it's
Thanks.
different things, different data. Okay, so again, I just want to emphasize that testing, not so much in terms of statistics, but it indicates something. And if you take the first one here, network activity, this is what we call collective actionability, and the specificity on the y-axis. And what we see here is a slowly decreasing trend. Again, I wouldn't be the theory based on this, but it still shows that in our case, in this case, having more links doesn't make you more able to have a high specificity in management. So these results would essentially say the more links you have, it doesn't mean that you're going to perform better. But I really want to say there's probably a bottom limit to that. So you need to have some links. But if you have 20, if you have, in this case, if you have 5 links per person on average versus 7, doesn't really change much. So no support for that hypothesis. Then we have this collaborative, now we have homophily on the x-axis. So I mean, if you have more of that collaborative heterogeneity, you would be closer to heterogeneity. And we see a trend here, we have this outlier, but the trend is very kind of weak. But the trend still indicated if you have more of that collaborative heterogeneity, you have a higher number of links between actors with different backgrounds, you do better in terms of system integration. So kind of weak support for that hypothesis. And then we have this coordinated centrality, meaning that instead of having all these different actors with different background connecting to each other, this is more like if they connect to the project leaders, it is getting to centralization. And we see the same thing here, like if you have, the higher you have that centralized heterogeneity, the more you have a system thinking in the management. So again, weak support for that hypothesis. And then the final one, transitivity, number of triangles, more or less, with the tendency of forming triangles, and then anthropogenic specificity, that is essentially solving conflicts. And slightly, there's a trend upwards here. So again, some support for that hypothesis, that it's good to have these close triangles if you want to deal with conflicts. And let's see what I had here. So again, I think I just went through that in terms of trying to figure out if those hypotheses were supported or not, and mostly yes, I would say. And the reason for showing this is that I thought it was a good example to think about the causality thing, because I have a lot of assumptions here. But using the Coleman mode now, a couple of years after, for me, it was easier to explicate those ideas about why would a certain network structure be good or bad for that specific kind of outcome, or that specific ability that would lead to that certain outcome in terms of the qualities of the management plan. Yeah, I think I just talked about that. So having many social ties is not necessarily making collective action better. And it seems like that heterogeneity can be utilized in 2 ways, at least. One of them is for these different actors to actually come together across these different types of backgrounds. But it also works, according to this data, if you have a centralized person that can essentially bring these different knowledges together. So both of these different ways of utilizing heterogeneity seems to be working. And transitivity seems to be working as well in terms of dealing with contested problems. That was essentially the summary. But now that was half time through, and now we're going to talk about what I was supposed to talk about. And I thought this was a kind of a warm-up thing. And I have 1 hour, which is great. For me, at least, maybe not for you. So let's get into social-ecological. So I'm talking about social networks now. But environment is also there. And if we talk about human nature interactions, I think in some cases, actually many cases, it might be quite good to bring in nature in that social network. Depends a little bit on the context and everything, but if we say that human nature interactions matters, I think it would be good to actually bring that into the same equation, more or less. And that's where I'm using, or we are using, the social-ecological network approach. This is an example of how it could look like. So what we have here, this is from Madagascar. So the social actors here are essentially villages. And they are nodes in a pretty small social networks, but you still have some structural tendencies in this network. And these different villages have access to different forest patches. The forest patches in this case also forms nodes. Oops, back. So that would be like one node in this social-ecological network, a forest patch. And then of forest patches, they are also interconnected from a biophysical point of view, like, for example, seed dispersal. So these forest patches themselves form a system, ecosystem. Patches and their relationships. You have the villages and their social relationship, and then these different villages are utilizing these different forest patches. Not all of them, some of them. That's why you have link between them. This is a social-ecological network model. You can also think about that in a more abstract level. So the starting point here with the left would be like you have a social system, you have an ecological system, and there's some kind of link between them, and many people are arguing for this. But then you can increase the level of resolution, as we pointed out here. Instead of saying you have a social system, you can say you have a social system because it's different entities. Same thing here with another one. These entities are connected in various ways, and they're also connected across these system types. That's the social network. But of course, that's just a model. So how can we use that? We can make models of everything. It's purely descriptive. So, and we want to use this model to say something smart, hopefully, about human nature interactions. And what we did here in this paper was to, instead of trying to figure out what could happen on a more global scale or macro level scale, we thought about very small, tiny social-ecological networks, because it's much more easier to relate that to theory, I would say. I'm just going to show you some examples of that. You can think about more of these configurations of building blocks or motifs, or there goes the one different names. But again, the basic idea is to make it easier to think about social ecological network structures and implications for outcomes and governance and essentially behaviors among the actors. We'll take the first one. It's probably the most basic one. It's, I would say, very important configuration. So you have two building blocks here. You have two actors, one resource. Both actors are utilizing that resource. That's why you have links from the actors to the resource. There's no link between the actors, no social tie between the actors. In this case, same setup from a human nature point of view, but now you also have a link between the actors. Very simple configuration. But simplicity is the key here. So in this case, with that situation or configuration, you have a competitive situation. You have two actors competing for the same resource. They don't communicate, which means that there's a high risk, I would say, and this is based on cohesive theory, it's very well-developed research by itself. If you don't have those links, the ability for those actors to agree upon more sustainable use of the common resource is reduced. It has to rely on someone else, regulations, police, institutions to be taken care of. But if you have this link between them, you have increased the probability or the likelihood for those actors to come together and agree upon some measures to avoid, for example, overharvesting. Having a link doesn't mean that you don't do that, but at least you increase the chances that you can come up with agreement. And it's important to keep that in mind. The social tie doesn't mean that you're going to work together and everything's going to be fine, but if you have a social tie, you have increased the likelihood that you can find an agreement. So, from a management or taking care of that resource point of view, this configuration would be preferable with that configuration based on common resource management theory. Think about this from a Kuhlman's mode perspective, and I put circles around both the node level and the diode level here. Node level, because if you are one of those red dots here, one of the actors, that position in the social-ecological network creates context. That position, this configuration, illustrates that you are in a competitive situation. So it's an effect of the network structure on the individual. But here also, if you have this link, if you have that link, if you don't have that link, it has a diode level effect as well. So suddenly these two actors that are competing for the same resource do have a link, and they can use that, could influence their actions, which could then influence the system level outcome. So I'm interpreting this in terms of common board thinking. You take another one. And we call it the internalized ecological externalities. And I think we choose that word or phrase to make it hard to say. That's probably the reason, because that's one way to distinguish ourselves from others. Okay, so in this case, we have the configuration. You have only one actor. That actor is using one resource, but the resource is connected to another resource. And that other resource has no connections to the actor. And you can think about this in terms of externalities. So if this actor is doing something with this resource, it's going to have an effect on this other resource, but that's not the problem for that actor. It's externality. Whatever goes on, whatever kind of side effects of your activities on that resource, whatever kind of effects they would have on this other resource, that's not your problem. So you have an externality. But if you are also utilizing that resource, you are also the one taking the consequences of those actions. So you have closed the feedback loop a little bit between the human and nature, yes? Tighter feedback loop. So then this would then, according to that reasoning, be more favorable configuration than this one. Sometimes it's called scale matching, scale mismatching if you don't have that match. In terms of the Coleman boat, this is a node level thing from a social actor point of view, because it's just one actor. But the position here is, the position is in relation to the ecological resources. But I also put in a diet level thing here, because this is a diet level effect between the actor and the resources. So the way the actor are utilizing the resources could have an effect on how the actor acts. That's why I have a kind of dotted circle. That corner of the boat relies on seeing the resource as an actor in a way, or entity that has a meaning in terms of influencing that actor's behavior. Okay, and then the final configuration we have here is a little bit more complicated, still simple. Two actors, two resources, but these resources are interdependent. So you have a similar problem as the previous configuration. And also following the same reasoning as the common for resource management, if you have these interdependencies between different resources, you have two actors, these externalities are not a problem, and it's going to be the other person's problem or actor's problem, and that actor, you have nothing to do with that actor from social point of view. If you have some kind of link between them, at least to increase the probability that they might be able to address these interdependencies in a more coherent way. So this will be then the preferred configuration over that one, based on that reason. Coleman both again, this will be like a node level and a diet level effect. So that this is the configuration, and if you have that link, it could change that. That's the idea. But then, of course, a real network is more complicated than 2 or 3 actors, or 1 or 2 actors and 1 or 2 resources. So the idea is to look at the complete social-ecological network and think about how often do you find these different configurations in that network. It tells you something. It's a way to quantify the network in terms of those building blocks that we have just assigned some expectations and theory on. Which means that instead of just looking at deep message nodes, we can hopefully say something about the structure of the network and using these assumptions about how it could affect causality assumptions. Essentially, we might be able to say something about both how the actors in this social network might act, but also how the group of actors as a whole might be able to manage the resources. So but when doing this exercise, just figuring out how often you find these different configurations in the network, what we're doing there is essentially measuring something at network level, and we compare that with the global outcome, if the outcome is measured at the community level, or the network level. I said I should say something about exponential random graph models, and if you just, this is like a topic for, it takes a long time. I just want to say that even though here we just counted the number of times you found those configurations, You can do that, but it's far from the best way to do it. I would definitely recommend using an experiential graph modeling for this. And there has been since quite some time now this multi-level extension to ERGs. So you can use ERG out of the box and PNet and do this ERG stuff on a social-ecological network, and we will do it. And it addresses many of the problems that you would have if you just count the number of times you find those configurations in the network. But I'm not going to say more about it. But if you want to do this, use experiential graph. Okay, skip that. I just want to show some results. So we did 2 studies using this approach. The first one in southern Madagascar, and I talked about that. They have villages living in this landscape. They utilize different forest patches for various reasons. And based on that, we have the social network. I just showed that. That's like a fancier picture of the same thing here. And then the other study area was a small-scale fishery in East Africa. So what we have here is a very fishery-dependent village. Fishing is basically the main occupation or main income in this village. We have significant fishermen groups, and we have measured together the social network data among the fishermen, like to who you turn to get advice for where to fish, what bait to use, and techniques, and so on. And we also know where they fish, what kind of fish species they are targeting, and so on. And based on that information, we came up with that social-ecological network describing this fishing community. So here we aggregated the fishermen based on the gear type they use, because they tend to aggregate based on the gear type. So if you're using spear gun, it's much more likely that you have a spear gun as your friend versus gill net user. But you also have links between these fishermen groups. This is an aggregated picture of the fisherman network up here. And what we see here would be the target species. So they are targeting different species. It's a multi-species fishery. And some of the species are predators species fish. Most of them are prey species, which means that you have links between different fish species. And that would be the black links here. This is trophic interaction. Who eats who? So that's an ecological network. And you have the fisherman network. And again, they're targeting different fish species. So not all of them are targeting all the fish species. You have a variability. And then I want to see, like, can this approach on focusing on this small building block configuration thing explain why one of those cases, which actually is the Madagascar case, are doing reasonably good in terms of conserving the resources. And we say that because these forest patches have been there for a very long time, even though there's a lot of, there's pressure to use the forest patches for coal production, there's an increased population pressure and so on. So from a conservation point of view, we consider that to be the more successful case. Whereas the small-scale fishing in Africa, clear signs of degrading fish stocks. The fishermen themselves are complaining that the fish stocks are going down. You have to fish longer to get a certain amount of fish and so on. So we consider that being the less successful case. It's a very simplistic way to think about it, but we still use them as two kind of contrasting cases in terms of preservation of resources. And then we got a network, I showed them, and then in this case, we just compare the frequency. How often do you find these configurations in the network? Trying to control the different densities and so on. Again, this is not the best way to do it. You should use ERG. We actually did that in the later paper, more or less the same results. I feel a bit confident presenting the results here. So what we see here in that, so we have the two cases here. The first one being the most successful case, that's why I have a plus sign there. And what we see here is to have a significantly higher number of close triangles than expected by chance. So if you randomize that social-ecological network, you would have that number of ties. This is distribution, the blue bars. And the red bar is what we actually found. This is significantly higher than by chance. And in the less successful case, we see the same but the opposite. You have a significant underrepresentation of that configuration that we deem to be a good configuration in terms of possibilities to agree on more sustainable management. And then if you take the kind of the mirror image of that one, this is the same configuration, but without the social tie. And then we see in the first case, it's a strongly significant underrepresentation of this configuration. It's quite rare to find this one in this case. Whereas in the small-scale Fisher case, this is as expected by chance. There is no deviation from chance. So we see that. Okay. And then the scale fit thing is kind of externalities, internal. I can't say that. So what we saw here is that in the more successful case, you have a significant overrepresentation of that configuration, whereas in the small scale Fisher, you have a significant underrepresentation. And then we take the opposite of that, where you have that possibilities for externalities, and it's significantly underrepresented in the agricultural landscape, and it's more or less by chance in small scale Fisher. So if you take all of this together, we support, I would say, for hypothesis, but also for the method. It seemed, still based on two cases, so maybe shouldn't be the theory on that, just these two cases. Good point. I think you would want to say that, but it indicates that this might actually tell us something. And this was quite a few years ago. So there's been many more, not super many, but there's more studies focusing on these configurations. And so far, the results are pointing in the same direction, at least for these configurations. In particular, for the one that has to do with resource competition and collaboration, I would say that is now fairly well supported using this approach. These other configurations being a little bit under the test, but more studies are coming out, and I think they show that this way to think about human-nature interaction can help us to understand something about why people behave in certain ways, why communities behave in certain ways, not only based on how they collaborate or do not collaborate with each other, but also on how that collaboration relates to how they connect with nature and how the nature itself is being structured in terms of interdependencies. Okay, so far, summary. Collaboration can improve environmental management governance, definitely yes. But I think it's important to think about collaboration in relation to how actors use environmental resources. And as I showed in this Coleman boat examples, the dyadic effect on behavior could be quite beneficial. In that, it can be beneficial to think about that dyadic links also in terms of actors and the resources, and not only about actors and actors. Okay, am I running out of time? I think I'm. Do I have 5 more minutes or more minutes? Okay, good. And coming back to the first, to the case where you can think about the network as the dependent variable, and how can we use a social network or social-ecological network approach to think about that as well. And this is just an example using the same configuration, but in the previous study, we were using the configuration to try to explain an outcome. And the right-hand side of the Coleman bathtub. But think about that from the other side of the Coleman bathtub. Why do we have a certain network? And in this case, you can think about these two actors competing for the same resource. And the question might be, how are they going to act upon it? Are they going to form a tie or are they not going to form a tie? So this is more about explaining if there's a tie between them or not. So the situation, the context, the micro level context is that they are competing with one resource and they have to make a choice how to deal with that. And to simplify things, you can think about 3 different options. You can choose to try to reach out to your competitor and come up with some kind of agreement, or you can just forget about it. Don't try to reach out to that person, or you can actually engage in a fight with that person, try to outcompete. It was more like a conflict-oriented approach. And if you measure that as a social network, you can think about this like this: a collaborative tie or not? Is there a tie or not? Or is there like a negative tie, like a conflictual tie? Because we can also measure that clearly. So then in this case, if they have a collaborative or a negative or a more conflictual tie, it tells us something about how the actors choose to act given this situation. So it tells us something about why, maybe not why, but at least tells us something on how these actors choose to address this situation of resource competition. And you can think about the same problem in many other configurations of socio-economic interactions. This might be the simplest one in terms of this is competition. But you can also think about this in terms of the more complicated buildings. If you are situated in a more complicated contextual situation, how do you choose to respond to that? Do you choose to respond by forming a collaborative tie? Or do you do something else? So I think this perspective can also help us to understand a little bit on their choices. Not necessarily the outcome in terms of being good or bad and managing them. Also like, why would they even consider to engage in collaboration? Or why not? I have like 20 more slides, but I think that would be aiming too much and we are out of time. So I think it's probably a good time to stop. Thank you very much.